So this is going to be our last practice question with stoichiometry. All right, you can find this same question as the sample problem on page 307 in your textbook. Again, I'm just changing the numbers a little bit to switch things around. So in our question, we are given the chemical reaction nitrogen plus hydrogen yields ammonia. So N2 plus 3H2 yields 2NH3. And the question reads, what mass of NH3 can be made from 821 grams of hydrogen and excess nitrogen? So we're going to be going through the same process. We're going to start with what we're given. We are going to identify what we're looking to find. We will be using a mole ratio at one point in the video, and that's going to be important. At which point are we supposed to use it? We are given excess nitrogen, so again, I want you thinking, anytime you see that word excess, we don't have to worry about the nitrogen at all. It is an excess. There is as much of it as we need. And this question is good because it's the most practical in a lab setting. All right? We're being given a mass of hydrogen to start with. It'd be like if we had a scale and we measured out 821 grams of hydrogen, and it would be like if we were to take our product, the ammonia, and put it all in one spot, put it on a scale, what mass would it read when it reacted with all of that excess nitrogen? All right. This question may seem a little confusing because they're gases, but we'll be doing a lab next week with copper. So you're going to be starting with a certain amount of something. You're going to end with a certain amount of pure copper. So let's go through this question. So what we're being given is 821 grams of hydrogen. And I hope you're beginning to see what you're given is always going to be a number. You're going to be given some amount of one of the reactants or products. In this reaction, we are given 821 grams of hydrogen. What we are being asked to find is the mass of ammonia, the mass of NH3, and the mass is the same thing as saying grams. So don't get confused if it's asking for mass. It's the same as asking for grams and vice versa. So we're going to be doing three main steps to solve this question. Our first step, we are going to convert the grams of hydrogen to moles of hydrogen. And at the beginning of a stoichiometry question, we're trying to work towards moles because we need to use the mole ratio. Mole ratio is the most important part of stoichiometry, so anytime you're not given moles, you should be thinking, how can I get to moles? Step 2, we are going to use the mole ratio. We're going to go from the moles of hydrogen to the moles of ammonia. We've seen the mole ratio before. We're going to be setting up a fraction. And step 3, we are going to convert from the moles of ammonia that we're hoping to get in step 2. We're going to convert those to grams of ammonia. And if we look back at our find, it's to find grams of ammonia. So once we complete step 3, we should feel real confident that we've answered the question and we are done. So our molar mass of hydrogen, and I wrote out what hydrogen would look like on the periodic table, is its subscript 2 multiplied by 1.00, which is the molar mass of one hydrogen atom, but there's two hydrogen atoms in a hydrogen molecule. So 2 times 1 equals 2 grams per mole. Okay, so that's just finding the molar mass of hydrogen. Now, mass divided by molar mass equals moles. And if you look at your units, you're doing grams divided by grams per mole. So anytime you divide by a fraction, you're multiplying by its reciprocal. So technically you're doing grams times moles divided by gram. Grams will cancel out. That can get a little confusing sometimes. Just remember, mass divided by molar mass equals moles. All right, so the given mass of hydrogen was 821 grams. We are dividing that by 2 grams per mole. and we are going to get an answer of 410.5 moles of hydrogen. So we're starting out with a massive amount of hydrogen because if we think about it, 821 grams of one of the lightest possible molecules, you're going to get a lot of moles. And one thing I want to point out here, this is a very common mistake that kids will make. I didn't use the 3. I did not use the coefficient of hydrogen at all. The coefficient does not affect the number of moles. We'll take care of it in the next step with the mole ratio. But whenever you're finding the moles for a reactant or a product, do not use any coefficients. Only use the subscripts contained within the chemical formula. Okay, that will guarantee that you don't make any simple mistakes. Our mole ratio in this equation is 3 moles of hydrogen is equal to 2 moles of ammonia. And I'm not going to go on another rant about how, writing 3 equals 2 wouldn't make sense in a math class, but writing 3 moles of hydrogen equals 2 moles of ammonia with this given chemical reaction does in fact make sense. But let's make sure we remember what was given to us in this question and what we're being asked to find. Now, we were given hydrogen. We weren't given moles of hydrogen. We were given grams of hydrogen, but we were given hydrogen, and we just converted it, and we're asked to find ammonia. Now, we're not being asked to find moles of ammonia. We're being asked to find grams of ammonia, but for right now, we are just trying to find ammonia. So we're going to do 410.5 moles of hydrogen times the mole ratio, and again we want to put the coefficient for what we're looking to find on top, the coefficient for what we're already given on bottom. So we're multiplying that 410.5 moles of hydrogen times 2 moles of ammonia divided by 3 moles of hydrogen, so 2 over 3, and we're going to get an answer of 273.7 moles of ammonia. I got 273.66 repeating, and I rounded that to 273.7. Again, we're playing a little loose with the rounding rules. I'm not going to get too upset as long as I see you doing the steps for these types of problems. The steps are more important to me than the math. So in our third and last step, we need to use the molar mass of ammonia. So the molar mass of nitrogen is 14. There's only 1 nitrogen per each molecule of ammonia, and there's 3 hydrogens. The molar mass of an individual hydrogen is 1, so 14 plus 3 times 1 is 17 grams per mole. Now, we know that we have 273.7 moles of ammonia from the mole ratio step, that second step. So now what we're going to do is moles times molar mass will give us mass. So 273.7 moles of ammonia times 17 grams per mole. The molar mass of ammonia is going to equal 4,652 grams of ammonia. And grams of ammonia is what we were asked to find in the question. So we are done. All right. I'm not going to do this one as a bridge, but if you want, try to set this one up as a bridge. Look at the practice problem on page 307. Try to set that one up as a bridge and work on the following question. All right, when I said I wasn't going to do the bridge, I lied. There's the bridge. All right, so all 3 steps are there, each part of the bridge. In the first section, we are dividing by 2. Okay, that's the molar mass of hydrogen to find moles. In the second step, we're multiplying by 2, dividing by 3. That is the mole ratio. And in the last step, we're multiplying by 17. That's the moles times molar mass step. So, hashtag easy money. We'll definitely work on the bridges in class. Just make sure you have the steps down for right now. So what I would like you to do now is to work on this question 24 from page 330 in your textbook. Okay, I'd like you to do parts A, B, and C just to practice working it with these questions given the mass and asked to find the mass in your end product. You're still using the mole ratio. Make sure you're using those coefficients only in that mole ratio step. Make sure you are converting back and forth between mass and moles when appropriate. Mass divided by molar mass is going to equal moles. Moles times molar mass is going to equal mass. So good luck with question 24 on page 330.